Hello everyone. Today I would like to do revision for the SPM exam 2021. So we will start with the first topic, which is function. So for functions, paper 1, we will focus on short question. So let's see, we will do revision on relation. Relations consist of order pairs, arrow diagram, and Cartesian graph. So this is a very basic relations. So let's see the question number 1. We are going to discuss the question one by one so that you are well prepared for your SPM exam. So number 1, based on the below information, you're given the information 1, 2, 1, 4, 2, 6, and 2, 8, right? So this is actually relation between the set P and set Q. So meaning that the set P is having the object 1, right? And then the set Q is having the image 2, 4, 6, and 8, and 10. So these are the set given, set P and set Q. For set P, you have 1, 2, 3. And for set Q, you have 2, 4, 6, 8, and 10. So what is the image of 1? So as you see the image of 1, that means so let's see the image of 1. So it seems like we have 1 mapped to 2 and 1 will map to 4. So we say the images of 1. Images of 1 we have 2, 4, right? So we have 2, 4. And what is the object of 2? So the object of 2 means the 2 is the image. So that is how we identify image 2. Image is 2, so the object of 2 is 1, right? So the object of 2 is 1, and the images of 1, that means this is object. So the images of the 1, we have 2 and 4. So we have 2, 4 for images of 1, and we have the image. Okay, image 2, we are having object 1. Alright, so this is the answer for question number 1. So we must really understand image and object. Okay, so example here, image of 3 is 6. So this is the image, and object of 6, that means 6 is the image, object is actually 3. In short, when you see image, meaning that image of 3, that means you need to find the y. That means you are given the x, right? When you are given the object of the 6, that means you are given the y and you need to find the x. Alright, so the function notation, meaning that you have to form the relationship between the x and y. So it seems like x is equal to, okay, let's see, we have x is mapped to fx. So we have 3 maps to 6, 4 maps to 8. So if we have the x, it will maps to 2 times. This is 2 times 3, this is 2 times 4. So this is 2 times the object is x, right? So the function notation is fx equal to 2x if the question asking for function notation. Now let's see this one. The diagram shows a relation between set P and set Q. So domain is set P and codomain is set Q. Object we have D, E, F, and the images we have X and Y. Make sure the images are mapped with the arrow. So the range of relation, when we see range, is always come with the braces. Type of relation, meaning that it belongs to 1 to 1, or 1 to many, or many to 1, or many to many. So if it is 1 to 1, okay, it will be something like this, right? 1 to many, many to 1. Okay, this is number 1, 1 to 1. This is number 2, 1 to many. And this is many to 1. And then the fourth one is many to many. Okay, please remember the function, the type of the relation. Okay, so the range of the relation, we must make sure it is connected with the object with the arrow. So obviously it's x, y. It must be written in set form. And the type of relation, of course, you can see two object maps to one image. So it's many to one, even though you have 1 to 1, but it's combination between 2 to 1 and 1 to 1. So we say it's many to 1. Alright? Okay, let's proceed to the next question. So for this question, the diagram shows the relation between set x and set y in the graph. Okay, so we can say that this set x are domain and set y are the codomain. So the object of Q, meaning that we will connect the Q to 2. So this is the object. So the object of Q obviously is 2. Okay, the codomain of relation. Object of Q is 2, so this one should be 2. It's not 2, 6. Objects of Q. Or we have 2, right? So it's 2 and 6. So objects normally we don't write in braces. Okay, we will just write in without braces. So objects are 2, 6. We have 2, right? You look at here. We have 2 point here, and then it's showing that the x are 2 and 6. Okay, codomain of relation. Codomain meaning that we have to find the set of the elements in set Y. So we have PQRS is a set, okay, codomain. So alright. Now let's proceed to next one. The diagram shows the relation between set X and set Y in graph form, in the graph function. So set Y is codomain, set X is codomain. So the relation in the form of order pairs. So we have to list out the order pairs. Order pairs is always X followed by Y. So your answer should be 1P, 2R, right? This is this point is 2R. This point is 1P. So we need to list out all the point in terms of the object and image, 3S. And we also have one more point here, which is 4P, right? So we have 1P, 2R, 3S, and 4P. And the type of relation, let's see. If we draw the arrow diagram, then we can have a very good relationship between the object and image. So we have 1 maps to P. We have 2, 4 also maps to P, right? Look at that. So it seems like type of it should be let's see, 2 maps to R, and then 3 maps to S, right? So it's actually many to 1, right? It's a many to 1. Obviously looks 2 arrow pointing to one image. Okay, the range of course is PRS, right? We have P, we have P, we have R, we have S. Repeated one we write once, so it's PRS. So the range must be in a set form. Okay, so let's proceed to the next one. It is given that relation between set X, okay, you're given set X and set Y is a square of the image of 9. Square of, okay, the image of the 9. That means square of 3 will give the answer 9. Right? So find the image of 9. Image of 9 is 3. So express the relation in order pairs. So that means if 0 maps to 0, and then 1 maps to 1, and then 4 maps to 2, and 9 maps to 3, 16 maps to 4. So we can say that the relation in the form of order pairs like this. Okay, we list out in order pairs. Okay, so alright, is actually the square of 0 is 0, square of 1 is 1, the square of the 2 is 4, right? So let's proceed to the next one. Okay, for this question, the diagram shows the relation between set M and set N. So this is domain, this is codomain. So the object of 1, let's see, object of 1. That means 1 is an image. Okay, object of 1, so that means we have the 6, right? Is an object. Okay, so this is the answer. The range of relation, range, we make sure we identify the one which are images in a, okay, we circle, we have -1, -3, we have 1, you have 3. So a range are elements of the images. Okay, so we have complete the discussion about object and image. Represent the relation in the form of order pairs. So order pairs, we have the -2 will pair with 4, and then 1 will maps to 1, and 2 will maps to 4, right? It seems like 2 maps to 4. So the order pairs will be in a basis. We need to write the it's a set. State the domain of the relation. Domain will be a set consists of all the object domain. Alright. Now let's see, for functions, explain a function using graphical representation and notation. So for function, you will be asking how to use a graphical representation and notation. You have to determine the domain and range of the function. You have to determine the image of the function when the object is given, and vice versa. Function notation. What is function notation? Okay, function notation show that set B show the image of certain elements of set A. So let's see, we try to figure out if 5 go to 25, what you do, you square it. In 4 go to 16, isn't it you square? This is -4. -4 also you square, get 16. -5 you square, you get 25. So the function that you will write is x will be x squared, right? So the function notation is f of x equal to x squared, right? Okay, so state the type of relation between the A to B. It seems like is two object go to one image, right? And then if you study another one, you will see 4 and -4 will go to 16. Two objects go to one image, so it's a many to one. Using the function notation, write a relation between the set A and set B. This one was discussed just now. Okay, let's see this one. State the value of M using the function notation, express H in terms of X. Okay, so in order to find the value of M, we need to figure out if 0 become 1. So 0 become 1, 1 become 2, and then 5 becomes 6. So you can say that you plus 1 for 0, you get 1. You plus 1 for 1, are you getting 2? So if in this case you plus 1, and plus 1, you get 4, because it seems like the pattern is plus 1, right? So the M should be 3, right? Okay, that's how you work out the answer. a function notation of h in terms of x. So of course the function h, this is a h, will bring the x to x plus 1, right? You can see from there the pattern number, right? It's a relation. Okay, this relation between the object and image is called function notation. Now this one, the condition of existence, okay, the condition such that a relation is a function. This is very important for KSSM. So the diagram shows the relation between x and y. So if you look at the graph here, this one, this is very important. I just want to highlight to you. You draw a vertical line test, vertical line. This is a vertical line test. So a function, we have one-to-one, we have many-to-one relation. Okay, whereby you notice that is y is just 1. X can be many, can be 1. Meaning that each object must have mapped with an image. Alright, so that means you must make sure you have one image. Okay, so for graph, image means y. Okay, so in short we say we have one y value. So we have to draw a vertical line and it cut the graph only one point. Right, you see it cut the graph only one point. Draw a vertical line, whether the graph is a function or not. So you see if it cut the graph, okay, at 2 points, like this, determine whether the relation is a function or not. Give your reason. So if it cut at 2 points, meaning that you got two values of y, here y1, here y2. You have two values of y, meaning that you have two images. But according to the definition, okay, we know that function is either one-to-one or many-to-one, whereby we only have one value of y, right? So obviously this is no, because this is a one-to-many relation. Okay, because it got two y value. So if you have 2 point, vertical line cut the 2 point, that means you have two values of y. Two values of y means you have more than one image, right? So it's actually one-to-many. Alright, you can see that 1x here, 1x you have two value of y, see or not? Example, if you can say this is 2, x here 2. So 2, you can say that this is maybe a positive value, maybe 4, and here maybe it is a negative, something like that. So you have two values of y, so that means you have two images. So it is not a function, because for function it must be many-to-one. That means for function must have one y value only. Okay, so this is a one-to-many relation, and it's not one-to-one or many-to-one relation. Okay, only one-to-one or many-to-one are functions. So your answer, you can answer like this. Your statement, you must say no, it is one-to-many relation, or else you can use another way to answer. You can say not one-to-one or many-to-one relation. You have to give your answer to justify the statement, whether it is a function or not. So this is a very popular question in SPM exam. Now the diagram shows the relation between set P and set Q. So you notice that there is a modulus, right? So determine whether the relation is a function or not. Give reason to your answer. Let's see. It seems like you have one image, one y, one, right? Many-to-one, and consists of one-to-one. So your question is asking you whether relation is a function or not. we notice that this object does not has any image, right? So obviously no, because the object 1 has no image. Okay, so be careful, even though it's many to 1, but it don't have the image, which is not a function. Okay, so diagram shows the function hx. So when you see x, you can always substitute the 8 inside. So m minus 8 over 8. Then the hx, meaning that it's negative half, right? Okay, so you just solve it. Okay, you just solve it. Cross multiply. Negative half times 8, you get negative 4 equal to m minus 8. Then your answer m will be equivalent to positive 4, right? Now let's proceed to another one. So you have the function fx. You see I highlight the x is the object. That means I'm going to substitute with the p here, p, right? So we will substitute p into the x. Then the fp is 4, right? So you can say fp is 4p minus 3p. You will reach this answer. So p is negative 2. Alright, so let's see this one. You have a function fx equal to x minus 2m. So if you want to find the m, you have to plug in the, we write the equation first, right? So you have to plug in the 4, and then is 4 minus 2m is equal to the image, which is 8. So that is how you solve it, and m is negative 2. Alright, so let's proceed to next one. Okay, so when we talk about maps onto itself under the function, you need to use a concept that the object and image are the same. That means the function h will bring the object to the image. We say maps onto itself, meaning that if object is x, image also will be x. Alright, so given a function, this one, find the x when it maps onto itself. So what you need to do is you must let fx equal to x. So you substitute x for your fx and you solve it. Your x is equal to 1, right? And then after you have the x, the value of h such that to function with the 2 minus h equal to 4h. So you just substitute into the function. So is 3, when you see x, you substitute 2 minus h. The rest you follow, minus 2 equal to 4h, and you simplify everything. Your answer is h equal to 4 over 7. Alright, so I have this cars maps onto itself already. 5 object will give you the image 5. Okay, when the function is defined as this one, x cannot be equal to h, meaning that 2x plus 3 cannot be equal to 0, right? If this is equal to 0, that means the function cannot function. So we have to solve the x cannot be equal to negative 3 over 2, right? If you bring over, so this is the answer. Okay, if x equal to 2 is unchanged under the mapping of the function, unchanged, that means object image the same. So we are going to solve the k. So we substitute x equal to 2 into the function, then we solve the k. Okay, so when the function is defined, that means cx plus d cannot be equal to 0. So when the question is undefined, the denominator will be equal to 0. Remember that? Okay, for absolute function, meaning that we are having modulus. So remember, when there is a modulus, when you solve the modulus, make sure you have a positive and negative here. Here positive, here negative 5. Right? So then you will have two answers. Okay, so the modulus concept, please remember, when you open the modulus, you will always have positive and negative k, right? Remember that? This is very important. Okay, modulus means positive and negative. Now let's see this one. The diagram show the graph function of the modulus function 2x minus 1 for the domain 0 to 5. Okay, for 0 to 5, domain is here. This is so-called domain. So when we say domain is always the x values. When we say range is always the y value. Okay. So let's see, I'm going to highlight to you the domain for the y here. That means we are focusing to the y value, okay, vertical value. So find the value of t. Value of the t is, okay, in order to find the value of t, we knew that the intercept, x-intercept is t, right? So for x-intercept, the y must be 0. So we will substitute into there. We will let, this is your y. So you let your y 0 and then you substitute x equal to 3. Okay, because you can always use a point here. Then if you try to solve modulus of 0, you get plus minus 0. So if you solve, you get t equal to half. Right, so the range of the corresponding given domain, meaning that for the purple one, the domain, you have to study the y value from minimum to maximum. So normally for range, we will write the value for the y from lowest to the highest. So here you have to find on your own. You have the 5 here. So you have to substitute into the function 2 times 5 minus 1, which is 9, right? So this is 9. That means y value is 9 for the domain 0 to 5. So you can write the answer like this. Make sure you have the inclusive of 0 and 9. Or you can give the answer like this. It's still acceptable. Okay, for this one, let's see. Find the, okay, the diagram show the graph of the modulus 1 minus 2x for the domain negative 2 to 4 inclusive of negative 2 to 4. The object of 7, object means we want to find x when given the y. So let's see the 7 here. We will try to find the answer for the x corresponding to the 7. So it's 4. The image of 3, that means we will study here. This is 3. We will find the image here. So it seems like it's the image of 3, f3, we can see obviously is 5, right? As you can see, okay, let me highlight to you. It's here, the 3 here. Okay, the 3 is here. So corresponding to 5. So this is the image 5. Okay, the domain of domain, they asking for domain, meaning that they will give you the range of the function for not inclusive of 0 and 5. So okay, let's highlight. Let's use a purple color pen, green color pen. I'm going to make it thicker. Okay, so 0 to 5 is somewhere around here. 0 is here, 5 is here. So we can see that the x, okay, that is the value of y. The x, we have to draw the vertical one to study the x is from here, which is negative 2 to this point, right? Okay, so we have to write the domain, which is the x. Since is not inclusive of 0 and 5, so the domain also not inclusive. If it is inclusive, then we have to take in the value of the x. So is it inclusive? I think yes. It seems like this one got this one we have to make sure it come with the line 0 to 5. So then our answer, we have to take in negative 2, and then for the other one is 3, right? Negative 2 and 3 inclusive. Okay, yeah, this is the answer, and make sure you write X. Okay, it is a must to write X, you cannot write Y. Okay, be careful when you write the domain. Okay, then for this one is you have to learn how to sketch the modulus graph. So basically when you want to draw the modulus graph, you can just draw this part first. Okay, you draw y equal to 2x plus 1, and after that you just shift down one step. So the red one is the actual graph of modulus 2x plus 1 minus 1, right? So then they ask you to find the corresponding range. So the range will be the vertical reading, right? So as I mentioned to you, this is the range. Okay, so from negative 1 to the highest, which is 7. So the range is always the values of the y from negative 1 to 7, inclusive of negative 1 and 7. So that's all my sharing for the modulus. Till then, I shall share with you more on function and quadratic function in my next video teaching. Bye bye and have a nice day.